Since it may be difficult to locate a short, it's a good idea to eliminate the possibility of grounds or opens first. After these possibilities have been eliminated, it's generally safe to assume that the problem is a short. In most cases, when a short exists in the stator of a three-phase motor, the motor has to be rewound. Take a moment now to check your knowledge of how a stator can be tested. This part looks at how two types of rotors can be tested: the wound rotor and the squirrel cage rotor. If a motor has a problem and testing the motor stator doesn't yield any answers, the next logical step is to test the rotor. The problems to look for in testing a rotor are grounds, opens, and shorts. Let's begin by looking at how a wound rotor can be tested. Let's see how a meg-ohmmeter can be used to test for grounds. The brushes are lifted out of the slip rings to separate the circuit into two parts: the rotor and the external resistances. To test the rotor, the meg-ohmmeter's ground lead is attached to the rotor shaft, and its line lead is held against one of the slip rings. Since the rotor coils of a wound rotor are connected together, the line lead has to touch only one of the slip rings to test all the coils. If no ground is present, the meg-ohmmeter will indicate infinite resistance. If a ground is present in any of the coils, the meg-ohmmeter will register less than normal, or perhaps even zero. If there is a ground in the coils, drying the motor may solve the problem. If it doesn't, the rotor will have to be removed and repaired. Now let's look at how the external resistances can be tested. The meg-ohmmeter's ground lead is attached to ground and the line lead is touched to one of the brushes. If the meg-ohmmeter indicates infinite resistance, no ground exists in the external resistances. If there is a ground, it can be located by following the wiring or by separating the circuit into small parts and testing each part. The next test we'll look at is the test for opens. A multimeter or an ohmmeter can be used to test for opens in the rotor circuit of a wound rotor motor. As with the test for grounds, the rotor and the external resistances are tested separately, so the brushes are lifted to separate the circuit into two parts. The slip rings are tested two at a time to measure the resistance through the rotor coils. The first and second slip rings are tested first, and the reading is 12 ohms. Then the first and third slip rings are tested, and the meter reads 12 ohms. And finally, the second and third slip rings, and the reading is 12 ohms. The results of the three readings should be similar. If there's an imbalance in the readings, there may be an open or a short in the rotor. To check the external resistances for opens, the tops of the brushes are tested two at a time. The normal resistance values are usually indicated in the equipment manual or drawings. All three readings should be equal. If there is an imbalance in the readings, there may be an open in the circuit. The next step would be to divide the external resistance circuit into parts and determine exactly where the open is located. The part in which the open occurred could then be repaired or replaced. If a very low reading is obtained during the test for opens in either the rotor or the external resistances, there may be a short in the circuit being tested. Also, if grounds and opens have been eliminated as possible causes of motor trouble, then it's reasonable to suspect a short. If a very low reading is obtained during the test for opens in either the rotor or the external resistances, there may be a short in the circuit being tested. Also, if grounds and opens have been eliminated as possible causes of motor trouble, then it's reasonable to suspect a short. When a short is suspected in the rotor coils, the rotor is removed and examined visually. Look for burn marks, which are a sign that a short has occurred. If you don't see any visual signs, the rotor can be placed in a growler to further test it for shorts. A growler is a device that can be used to induce an AC voltage into windings of a rotor or a stator for test purposes. The rotor is placed in the growler and a hacksaw blade, or another thin strip of steel, is moved around it. If a short is present in the rotor coils, the blade will vibrate. It's important not to touch the rotor's slip rings while the rotor is in the growler, because the voltage could cause a shock. If the rotor is too big to fit into the growler can be held against the side of the rotor. The growler and the hacksaw blade can then be moved around the rotor together to detect a short. Now, you don't have to worry about looking for shorts or grounds in the rotor of a squirrel cage rotor. The rotor bars are already intentionally shorted together by the end rings. And grounds cannot occur because the conducting bars are not insulated from the rotor. Opens, however, can occur. When a rotor bar cracks or separates from its end ring, an open occurs in the current path. Visual inspection of the rotor bars and the end rings may be all that's needed to verify an open in a squirrel cage rotor. Take some time now to check your understanding of how to test rotors. Sometimes it's necessary to disassemble a three-phase AC motor for maintenance or repairs. You may also need to disassemble a motor in order to locate a problem and correct it. In this part, we'll look at how a three-phase AC motor can be disconnected and disassembled for maintenance or repair work. The first step in disconnecting a motor is to follow approved procedures for locking out the motor from all potential energy sources. The power leads must not be touched until the power supply has been locked out and the leads grounded. Then the cover to the power leads can be removed and the power leads disconnected from the power source. Power leads are usually wrapped with insulating tape, which must be removed before the leads are unbolted. After the insulating tape is removed, the leads are unbolted. As each lead is unbolted, it's marked to identify it from the other leads. In this example, letters are used to mark it. It's very important for the leads to be marked correctly. If two of the leads are reversed during reassembly, the motor will turn in the wrong direction. And keep in mind that you may not be the one to put the leads back, so make sure that the marking is clear enough for someone else to understand. After the power leads have been disconnected and marked, the motor is disconnected from the equipment it drives. This is usually accomplished by taking apart a coupling. After the motor has been disconnected electrically and mechanically, it can be removed from its foundation and taken to the shop. When a relatively large motor is disassembled, special rigging techniques are usually needed to accomplish the disassembly. But the disassembly procedure is basically the same as it is for a relatively small motor. Now, disassembling either a wound rotor motor or a squirrel cage motor is very similar. However, with a wound rotor motor, the brushes must be removed before the end bells are removed. Let's see how a small squirrel cage motor can be disassembled. Now, disassembling either a wound rotor motor or a squirrel cage motor is very similar. However, with a wound rotor motor, the brushes must be removed before the end bells are removed. Let's see how a small squirrel cage motor can be disassembled. The first step in disassembling a three-phase motor is to prepare the work area by placing a cloth or a set of V-blocks on the bench where the rotor will be placed. The next step is to mark the end bells in the motor frame. The end bells are metal pieces that cover the end of the motor frame and support the bearings. The end bells are marked so that they can be replaced on the correct ends of the motor and lined up the way they were before the disassembly. You may hear these marks referred to as registration marks or witness marks. It's important to line up the end bells the way they were before the disassembly to prevent improper reassembly. The end bells can then be unbolted and removed from both ends of the motor. When the end bells are removed, the rotor is no longer supported by its bearings. Instead, it's supported by the stator. After the end bells have been removed, the rotor is lifted carefully out of the motor. Lift the rotor from the motor and place it on the cloth. Once the rotor has been removed, the motor is disassembled and ready for inspection. Take some time now to check your understanding of how to properly disconnect and disassemble a three-phase AC motor. This part looks at how a disconnected and disassembled three-phase AC motor can be inspected and cleaned. The inspection of a disassembled three-phase motor begins with a careful visual inspection, looking for anything out of the ordinary. For example, burn marks would indicate where high current may have caused excessive heating. If you're examining a squirrel cage motor, check the rotor for opens between the end rings and the rotor bars, and look for bent bars and for other damaged or broken parts. If the rotor is a wound rotor, check the windings for burns, which could indicate the presence of grounds, opens, or shorts. Also check the bearings. This motor has sleeve bearings. Sealed ball bearings are also commonly used. This type of bearing is checked by rotating it to make sure it turns easily and smoothly. If the bearings do not turn easily and smoothly, they must be replaced. Finally, inspect the stator. The entire stator should be checked for burn spots and loose or damaged parts. The condition of the insulation should also be checked. After the motor has been inspected, it should be cleaned. One method is to remove the loose dirt with a vacuum cleaner. Then the rotor and the stator can be further cleaned with an approved solvent. Both the stator and the rotor should be re-inspected after cleaning to detect any problems that could not have been seen because they were covered with dirt. After this step, the motor is allowed to dry completely. Then, after any necessary repairs have been made, the motor can be reassembled. Take a moment now to check your understanding of how to inspect and clean a disassembled motor. After the motor has been inspected, it should be cleaned. One method is to remove the loose dirt with a vacuum cleaner. Then the rotor and the stator can be further cleaned with an approved solvent. This part looks at how a three-phase AC motor can be properly reassembled and reconnected. The first step in reassembling a three-phase motor is to lift the rotor back into position, being careful not to drag it across the stator. Check the marks on the end bells to make sure the end bells are being replaced on the correct ends and in the positions indicated by the markings. If the end bells are not aligned properly, misalignment and binding of the bearings can result. After the end bells are replaced, they're bolted into place. At this point, the motor should be tested for grounds with a meg ohm meter and checked for balanced resistances with a multimeter to make sure that there are no electrical problems with the motor. After the motor has been reassembled and tested, it can be reconnected. We'll use a larger motor to see how this can be done. After the lead markings are checked, the power leads can be reconnected in the proper order and wrapped with insulating tape. The insulating tape protects the leads and also helps keep grounds from occurring. The first step in reassembling a three-phase motor is to lift the rotor back into position, being careful not to drag it across the stator. Check the marks on the end bells to make sure the end bells are being replaced on the correct ends and in the positions indicated by the markings. If the end bells are not aligned properly, misalignment and binding of the bearings can result. After the end bells are replaced, they're bolted into place. At this point, the motor should be tested for grounds with a meg ohm meter and checked for balanced resistances with a multimeter to make sure that there are no electrical problems with the motor. Now, before the motor is reconnected to the equipment it drives, the motor should be tested to make sure that it turns in the right direction and is operating correctly. Start the motor briefly. This is a procedure referred to as jogging the motor. If there are no problems, the motor can be reconnected to the equipment it drives and returned to service. It's also a good practice to check the current flow to each of 3 sets of coils in the motor. This can be done with an ammeter after the motor has been returned to service. Take a moment now to check your understanding of how a motor can be properly reassembled and reconnected.